Welcome to the Crazy Hat Chemist. So here we go again, the 15th video in atomic structure. So let's get moving here today. Bam! Alright, so we're going to be manipulating standard nuclear notations. And I'm hoping that you remember the standard nuclear notation that we discussed in the previous video. That's essential. The other thing that's essential here today is that you're going to grab yourself a periodic table, hopefully a little bit smaller than this one, and you're going to have that nearby handy. So what I want you to do is I want you to take a look at this whole entire chart here. This is really a chart, and we need to fill out the chart from the small piece of information that is given. We're going to fill out everything in this chart in a horizontal fashion. Not vertical, but in a horizontal fashion. Okay, so in the first one, we are given that we have iron 51. So right away, we know that it's iron because it says iron. So we know the symbol for iron by looking at the periodic table right over, bam, right over there. Okay? And then the 51 designates the mass of iron, of that particular isotope. Okay? And then what we need to do is look at the periodic table and determine what the atomic number is for iron. So we know the symbolic notation is going to be an Fe. We know it's atomic number 26. And then we're going to take that 26 will also tell us the atomic number, and that's the number of protons. That 26 will also tell us the number of electrons, and that's also 26. We're going to take the difference between the atomic mass, that's the 51, and then the 26, and that will give us the number of neutrons. Okay, so we're going to be filling these out in this horizontal fashion, and make sure that you take a look at this part of the video so you can fill out the rest of them. So what I want you to do is fill out the rest of this before you continue on with the video. So you're going to pause the video with your periodic table, fill out this chart, and then come back to the video and let it play on. Okay, so we're going to do this first horizontal row. Another key note here for you is that everything on this chart is going to be a whole number. There are going to be no decimal values, so everything is a whole number. That makes it very easy. So let's finish this first horizontal row, knowing that we just have the iron 51. Okay? All right. So the iron 51, it gives us the Fe, the 51 and the 26. Hopefully you notice that standard nuclear notation there. The mass is the 51. The atomic number is the 26. The 26 electrons is the same number as the atomic number. Okay, and the neutrons is 25. That's the difference between the 51 and the 26. Okay, the next one is with the bromine, and that was filled out here for you with the standard nuclear notation, so hopefully you can work yourself backwards from there. Okay, that is what you started off with, is that bromine. So it is atomic number 35, so you can walk yourself through the periodic table and find atomic number 35, then you correlate that with bromine. You should be able to spell bromine hopefully correctly. So how many protons in bromine? 35. How many electrons in bromine? It's a neutral element of bromine, so 35. Now to get the number of neutrons is the difference between the 76 and the 35. So you're going to subtract those two. The atomic mass is the 76. So this is an isotope of bromine, and we call it bromine 76. Notice that there's a dash in between there. That's not just a subtraction sign or anything like that. So hopefully those numbers worked out for you. So we're going to fill out the rest of this table in that same fashion. You're going to find out the numbers that you have. If you have the atomic number, then you're going to find that element on the periodic table. If you have the mass and the atomic number, then you're going to take the difference, get the neutrons, and use the atomic number. If you have just the electrons, you can get the number of protons, assuming that it is a neutral element. Okay? And so here, that is for the silver. Okay? And here is for the tungsten. And here is for the uranium. Okay? Hopefully this makes sense. There's a few things that you need to be particularly careful of that should just be like bright shining lights for you. In the standard nuclear notation, you should see that the AXZ, the Z part of it, is the atomic number, as in the iron is 26, and the bromine is 35, and the silver is 47, the tungsten is 74, and the uranium is 92. You should see that there's a consistency on this table here. The atomic number and the number of electrons are the same in the columns there. Okay? The masses, of course, correlate to the mass, and that is the A part of the symbolic notation there. Okay. Hopefully that whole thing, that chart works out well for you. You should be able to bounce back and forth with any part of that information that's given to you. Okay? Here's a little bit of humor for you. While I wear a hat at the same time, not that the hat relates to the humor, I don't think it does today. I don't trust atoms. I don't know about you, but I don't trust atoms. I hear they make up everything. Now, of course, this is excluding dark energy and dark matter, and that's a whole different story. I hope you enjoyed today's video. Give me a thumbs up if you liked that video. Subscribe to my YouTube channel, and I'll see you next time. Bye now.